Hi, my name is John Stout, chair of the National Technology Alliance Catalyst Committee. And we are kicking off I think we're four webinars into our Catalyst community moving forward, leading up to next year's MOSA Summit. So for those that don't know, and you joined because of the topic or the interest on value streams and how the Army Aviation is doing things, MOSA is Modular Open Systems Approach. It's an integrated business and technical strategy to help us achieve rapid fielding, overcoming technology obsolescence, faster response to threats, and a whole bunch of things. It's a Title 10 requirement. And we started the Catalyst community really as a result of the demand signal coming out of the MOSA Summit from well over 1,000 people that were there integrating things live, demonstrating that we knew how to do this. We know how to get technology into the field faster, but we need to deal with all of those other business related issues about how to navigate through government contracting, how to understand dynamic requirements, and how to change the way we do business in the DoD to achieve that Modular Open Systems Approach. So pleased to welcome everybody, and very pleased to welcome Mr. John Van Houten, the Assistant Program Executive Officer for Aviation, Engineering, and Architecture. So that's a mouthful. Engineering and architecture, two terms that have a very enterprise perspective, but PO Aviation doesn't necessarily have an enterprise history. They have a very, the historical approach to acquisition has been very much like the PEO needs to be very small, primarily just a support staff, just very, very little tax onto the PMs because they have money and their job is to go acquire an exquisite weapon system. And 40 years ago, that was the approach of let's go buy an exquisite weapon system like the Apache, and let's go field that, and let's go make sure that that system is very well done. So all the power, all the authority, all the control for making sure that that weapon system was delivered on time and on budget was with the program office. So PO Aviation went through this transformation to think about things from an enterprise perspective. So first thing, I'd like to know a little bit more about John Van Houten, the man, right? Where did you come from? What was your experience working in aviation and before that?
Sure.
And then a little bit about that transformation into an enterprise perspective, especially around MOSA, and then we'll get to the Agile stuff after that. So
yeah, sounds good. I appreciate it. And, appreciate everyone who's joining us today for this discussion. We are going to have some question and answer time later, so let's start getting ready with your questions. But a little bit about me. So yeah, I'm the chief engineer for PO Aviation. I have 10 years on the industry side, working I'm a computer scientist, software engineer. I worked with Motorola and General Dynamics for 10 years on, different DoD programs, the TACE system, Tactical Aerospace Integration System,
right.
And most notably, I worked on the DVE boards, the Integrated Visual Brownout, system. Also,
we own the night, let's own the environment.
That's right. And then also, I worked over at MDA, Missile Defense Agency, for a couple of years as the chief engineer for under C2BMC. With the overhead infrared persistent architecture for launch detection and typing of missiles. And it was an interesting time there as well. And so I have that 10 years or so on the industry side, about 15 years on the government side, working in, project offices as a tech chief. And
so, so very much understanding the business interest and how to map technology to requirements and how to get that under the traditional acquisition approach, how to get that technology into through the process and out into the field. Okay, excellent.
Yeah, I'm not a typical engineer, right? Mm-hmm. So I think I'm an engineer whisperer, so I can speak engineering and understand it. Even though I'm a software engineer, I actually hate software. Don't have to tell people that. Debugging killed it for me. Like I remember going through all the debugging classes, like, oh my gosh, error line 274 million. It was nowhere near that line, but I spent all this time. But I also speak the business side, right? The acquisition side. Talking to the user community and requirements and industry. And so that's actually given me a unique opportunity to help shape, where PO Aviation is going, not only from a MOSA perspective, but our weapon system and acquisition processes on the engineering side.
All right, fantastic. And so one of the interesting things that has happened with PO Aviation is kind of that consistency of leadership around this new direction. So you had the experience coming up through the acquisition community, understanding the business side of acquisition. And long about, a decade ago, PO Aviation started this process well before the legal requirement for MOSA to embrace open architecture on their platforms, to meet certain objectives. And a lot of that had to do with kind of the consolidation of budgets and the drawdown and the ability to manage such a large fleet with that budget. But that led to this whole series of actions. While Future Vertical Lift was starting, we were also losing money on modernization. We had to solve these problems. So there's been this handoff of leadership. I know a lot of periodicals talk about the fact that the change, the rapid change of program leadership, causes a lot of disruption in direction, right? So one PEO leaves, another PEO comes in. One kernel leaves, a PM, another kernel comes in, and the direction changes a little bit. The budget moves a little more slowly, but it could still be canceled programs and that kind of thing. We've stayed on course pretty well in watching what's happened at PEO Aviation. So talk to me a little bit about the movement in PEO Aviation from the historical model of acquisition to this new post-MOSA transformation world.
Yeah, I think a lot of the driver, really was cost, right? Availability of resources and funding. When we were in the global war on terror, we had pretty good budgets on the aviation side. I remember when a project office may have almost $1 billion, at least on the PM aviation systems budget, to be able to acquire and develop weapon systems. But as we started refocusing those resources, we realized, hey, the way we used to do business with excellence, and as Mr. Mason, our former, deputy PEO would say, we were silos of excellence. You had a Black Hawk silo, you had Apache silo, you had your UAS silo. And as the money started, drying up, it's like, okay, where are opportunities for us to not duplicate effort? Where can we converge on interoperability or, components? And so it was almost I like how you said, MOSA as an approach is really a philosophy. I think it's an engineering philosophy where we're looking at, okay, when I'm building a weapon system, what are the components that I wish I could change, that I should have, if I could have talked to the original engineers who set out on that acquisition pathway to get that weapon system, the pieces that I'm dealing with now, 5, 10, 15, 20, 30 years later, what do I wish I had more insight into to say, hey, let's make this more of a defined thing so I can make it a commodity,
right?
Whether it's a piece of hardware or a software, so I could I could change it out. A lot of folks, that I talk to, when I hear most of like, oh, you just want to, design to open standards and you're good to go. I go, that's a part of it. But I'm really looking at, designing to open standards that allow for interchangeability of components. What's the lowest level of severability of a component that makes sense, that allows for better competition,
right? For
better innovation, right? So I don't have to be stuck with a black box for 20 years, even though industry has already, quadrupled, orders of magnitude the performance, but it doesn't fit into my architecture. Yeah. And so PEO Aviation, really General Todd was looking at that, saying, hey, threats are emerging. The war is now different. They started talking about, MDO and JADC2 and how are we going to start fighting the future conflicts differently. We realized that we needed to be able to be more agile.
Right.
We also realized we had to be a lot more affordable,
right,
and we still had to be, sustainable. And so I think that was a lot of the driver that started, focusing, well, how do we do things differently as a PEO?
All right. Well, that's fantastic. And so I guess that positions you as the captain of MOSA for the aviation enterprise. And actually, that's our first question. Somebody wants to know what the story behind your hat is.
Yeah, no, great. Usually I like to open up things with a joke, but I always use the same software joke. So we decided today I'd wear the hat. So the backstory on this hat is this past June, my sister invited me down to the British Virgin Islands to go sailing with her and, and both my sisters and the family. And we had a wonderful week. It was great down there. And she had bought this hat and said she was going to award it to whoever had the most fun on the trip.
Right.
And so I was quickly nominated to be the chief party officer of the vessel Autopilot. And so I was then bestowed on this hat, which I had to wear to all offshore excursions at the different islands and then the events. And then they made the mistake of thinking I was an introvert as an engineer, of daring me to wear this all the way back from the BVI to Huntsville through customs.
Right.
So I did. So I wore it from the ferry from Tortola over to St. Thomas. I wore it through customs. I actually got, the only question, they looked at my hat and they said, we assume you have alcohol, don't you? I said, yeah, I've got a couple bottles. Hey, come on through. Wore it through the airport, on the airplane, through Atlanta. Atlanta was interesting wearing his hat. All good though. And so that's where it came from. But I'll go ahead and take it off.
Yeah, that way,
avoid the distraction.
We don't want the blame getting in everybody's way. But I will say it's an open invitation if you want to wear it on the expo floor. During the live integrations, feel free, by all means. We'll see. I'll go ahead and put a challenge out there. Anybody that joins this webinar that catches him with the hat and finds me after, I'll give you one of my drink tickets, right? First come, first serve. The first person to have a hat spotting gets my drink tickets at the expo floor. All right, anyway, so let's move on.
Sure.
Now, one of the interesting things, speaking of the expo, I think it becomes incredibly important as we start to embrace the concepts of Agile, and a particular topic today in discussing value streams is going to be around not just acquiring a thing, but what does the thing provide? And ultimately, when we're after solving common problems across the DoD, you mentioned MDO, multi-domain operations, and that means that we're solving a problem that spans air, ground, and possibly space and sea and cyber, right? So if we're solving a problem that may have multiple potential solutions, it's unlikely that any one vendor is going to have that solution set, which is a big part of the reason we do open architecture demonstrations, to show that we can move vendors out. But it also requires this coordination across the services, and that's a different kind of trick. So talk to us a little bit about the efforts in P-Aviation to reach out to and also to receive inter-service coordination around the concepts of open system architecture, MOSA, and then we'll move to value streams.
Yeah, no, so there's been a lot of great opportunity, and a lot of it's come out of the different MOSA summits and opportunities to engage with our, the Air Force and the Navy and our different partners. It seems that, when you look at, like I was just describing P-Aviation of having silos of excellence where we're going to acquire a weapon system, that was kind of across the board in all of DoD, where the Air Force would have, they'd be working on their C-130 or their next fight, the next gen fighter, and the Navy is working on, some of their aircraft or their different systems. And we realized that all of these systems have to have an architecture. They all need to have a governing set of standards, for interfaces, but a lot of them do the same thing. So if we were to make a Venn diagram of all the different weapon systems across the DoD services, we would see significant overlap, like mission processing is one of them. Sensors is another one, right? Avionics is another one, multifunction flight displays, communications. Yet there was no common, solution for them. Each service and within the services were designing their own unique solutions. And so what we realized, and I think the Air Force really did a good job, working on some of the reference architectures that they were putting out, even specific to missile systems, where they took and they said, okay, we're going to design a new missile, and every component of it is going to be interchangeable. Here are the standards from whether it's the propulsion, the munition, the guidance, so that we could have multiple vendors provide it as innovation, came along. So we've started discussing, hey, why are we all doing this in a vacuum? So the Air Force and the Navy have been really great partners. We have regular meetings with them about opportunities. Just recently, we're part of a memorandum of agreement between the U.S. Army and the Navy to look to leverage each other's architecture in a common way. That's gone up to the AAE for signature on both, the Navy's AAE and the Army's. And again, it's an opportunity for collaboration and reuse, so that we're not redesigning similar things.
All right, that's fantastic. Now, so when it comes into the things that we're sharing, I know for those that have been familiar with this, for anyone that's tracked the history through the Architecture Collaboration Work Group or the ACWIG, that there were things that the Army had to produce which are not traditionally just products, not in the way that the world tends to think of products. So Agile, in its usage in the software world especially, has been centered around, we think about Google's continuous beta, and that delivery of final endpoint communication. And one of the interesting things about defense acquisition is that the defense acquisition agencies aren't the producers of the thing. They're the acquirers of the thing from industry that produces it. So that creates a little bit of a paradigm of how you share these kind of intermediate organic products. And when I mean reference architecture as a product, a thing that we produce It doesn't go to the warfighter, but it's still got to be done correctly. And that product, to share it with the Navy at less than a whole system level, so they don't have to weed through it and find that common piece, we started to merge with this concept of component specification models and enterprise product architecture and things like that. So tell us a little bit about the history of that and how that impacts, how that moved into this emerging concept of value streams.
Sure. So, it's really kind of going down the thread of the system engineering V.
Right.
It's like, number one, what's the use case or capability that I'm being asked to develop or go after? Once I understand, how this item is going to be used, then it goes into, okay, what are my requirements that I can derive into a system spec or a software spec? And what we were starting to realize was, as the open model, like open software model, was really successful, that there was a lot of pushback on the DoD side saying, oh, it's open, it must be bad. It's going to be filled with, vulnerabilities, or it could be exploited. But what we also realized was, hey, having open consensus-based standards that can be adopted from an architecture or even a system perspective allows for better competition, allows us to refine, whatever we're going after in that acquisition. And so there was a huge push, like I said, when the money was starting to dry up, that we need to look at, well, from a value stream, what's the biggest problem when I go after something? It's usually bad requirements that I'll give to a vendor. I'll say, hey, OEM, I want X. And it needs to fly, and then we give them really crappy requirements. We don't actually give them good interfaces, and they'll come back with a design, and it works. But then when we say, oh, that's a great design, I really want to apply it to this other similar but related airframe or need, well, it's designed specifically for this. When we start taking, okay, if we take the approach of a component specification model, we're capturing all of those reference architecture elements and standards that would be applicable, and then they still get decomposed into component design models, right? Further, several levels down. So that way, we, as the acquirer, get to specify the capability that I need, the performance that it needs to do, but also how we would like it to interface with other elements. And because it's a overarching system, it's like we're looking at across all components. That then opens up the door for innovators and for vendors and OEMs to say, man, I got this algorithm that meets that need, but I have no way to get it on the aircraft. Oh, now I do. Now I know the defined standard for message traffic. Oh, there's a digital backbone. So I can take my, my software and load it onto a mission processor or my sensor. It's going to be routed the right thing. It can then be exploited.
Yeah, and I think one of the interesting things that I watched in the evolution of that, from my perspective, we talk about like how to write a good requirement. We have to some degree painted ourselves into a corner by having a very rigorous requirements process in the DoD. Now, back up 40 or 50 years ago, and that rigorous requirements process was designed to ensure that we weren't wasting money on testing when we had very hardware-centric platforms. And as we moved into software-centric platforms, this idea of being able to change a few lines of code and get very different behavior started to bring usability requirements in a very different way. You couldn't put your hands on it anymore, so you didn't really know if it was usable until you got it into its final configuration. And so this concept of making something user-friendly is a uniquely challenging concept in the software world, as opposed to make the car user-friendly from a physical design interface where you can actually see the evolution of that over its hardware lifecycle. And so software engineering institute did a lot of work on quality attributes, and I know we pulled a lot of that information into what we're doing. And I see that also as a precursor to some of the value stream, because instead of a performance requirement, we're talking about capabilities and quality attributes, and ultimately then delivery of value. So how did you first hear of value streams, and then how are you starting to apply them in the development of these component specification models and this work of producing products that people use to ultimately develop capabilities that get delivered to the warfighters?
So about 2 years ago, Mr. Bang up at ASALT put out a requirement for all, DoD civilians to take a Udemy course on digital literacy and value streams. It was about 15 hours of training. Didn't matter if you were an engineer or a program manager or a technical log, everyone had to take it. And this course had a series of modules not only on technologies and process, but but about what is a value stream from a business perspective. How does an action that you are performing bring value to the customer or to the organization?
Mm-hmm.
And so that kind of really started shaping the way we looked at things, not only from, like you said, when we opened up, a technology perspective, but a business acquisition perspective. How are we doing business? And so when we started to apply that to, okay, so when we're looking at any tangible effort, just because we used to do it a certain way, or because Jason's process said, here's how you develop a weapon system,
right,
there may be areas of value in that, and there were, but there's also a lot of waste. And any wasted effort is non-value added. So how do we become more agile, more affordable, streamline our process? Well, it goes back to, let's leverage kind of what the software community has done, right? CI/CD with agile processes, where you had the idea of minimum viable products, breaking things in. We said, okay, that's great from a software perspective, but how do we do that from an architecture overall weapon system? Again, it goes into, let's start breaking these functions into smaller modules that we can then define, and then we can get actually industry involvement, like the ACWIG.
Right.
Was a huge game changer in itself.
Actually, now you have the voices of people that might be competing against a future requirement talking about how should the interface be done fair, and now you've really changed the whole concept of requirements delivery and interface development, right? So it's a very different kind of conversation.
Yeah. And the way I looked at that, when I used to program, we would have peer reviews, software peer reviews, and we'd also have this, when we had extreme time crunches, we would do what we call extreme peer reviews. Where you had two coders working on the same code simultaneously, and a third was it's called a Fagan review, peer reviewing the code as it was being done to make sure you're meeting the requirements. Right. Bringing things through the ACWIG and through the Future Vertical Lift Consortium gave us an idea to say, hey, this is what we want to do from a government perspective. Industry, you're the experts in it. Bring us back your idea, and you get to check your peers' work. Right. Because we're actually asking for, please give us input into the development of this component specification model.
Right.
Your peer may say, hey, we got it. They give us really good stuff. But then another person can say, wait a minute, if we do it that way, again, now you're limiting competition or the ability. So it was almost like a extreme peer review for the industry. And one of the things that I've been amazed at all the last 3 MOSA summits is that industry is sprinting ahead.
Right.
They're embracing this. They're changing the way they look at black boxes and weapon systems.
Right.
They become way more agile, right? Because save time is save money.
Right.
Right. You can make more profit, by doing things faster and quicker and innovating. And so that's also, it's going to almost fuel the fire on the government side to say, okay, what do we need to do more of to enable industry to be that innovator, but then also to increase that competition? And it's going back through component spec models, component design models, and those opportunities to compete.
Great. All right. So one more kind of canned thing for mine, and then I'll get to some questions that we've got online. And by the way, go ahead and start sending those. Any questions that we don't get to today, I'll start to pull together kind of a continuous answering mechanism. We stood up the MOSA.net website, so we have a very easy mechanism to kind of deal with those questions, kind of sometimes turn them into articles, whatever the case may be. So we're looking for contributing information as we get this Catalyst moving further forward. And that will also involve some interchange events. We've done a couple of those kind of in-person events all day. We did that just inside the Army Aviation community with ACWIG All Hands and VLC members meetings in the years leading up to the MOSA Summit. And I envision doing a few of those again. I'd like to do one this spring.
Sure.
And I think about the component specification model, and it dawns on me that one of the complaints we got in the early days of MOSA was we don't want to fall into the LRU trap, where we went out and we bought a component, and then we made that a hammer to which every other thing was a nail. I've solved assured P&T. We're going to buy one, new EGI forever, and everybody shall use the EGI. And now we have 13 EGIs because there was no one that solved the problem. So I see that we could get into that same problem with component specification models, where we say, here's the Army component specification model for electric power systems. Somebody else says, that's a good 80% solution, but I need to be able to adjust it. So how can we take the concept of, we developed this product using this value stream and allow it to be shared with other services, maybe as a boilerplate, so that then we start communicating about how we created that product so that others can modify it and still keep kind of some canonical way to share interfaces and information. What are your thoughts on where that cross-service collaboration is going with value streams and CSMs?
Yeah, so like I mentioned, how we have this memorandum of agreement that's in the works of being signed between, the Navy and the Army, on architectures. We're also working two other efforts where, with our UK ally partners have requested the
pyramid program.
The pyramid program have requested access to the enterprise architecture. And so for those of you who may not be tracking at home, the FAF, architecture is now being consumed by the enterprise architecture. So the EA is the same as the FAF 4.3b. Everything in there, all the sysarcs, all the decompositions, and even the actual Cameo model links are exactly the same. However, we've now extended it to include, references for enduring fleet instead of a pure platform. And so, anyway, going back to your question, so when you think about the enterprise architecture of aviation, it's now the enterprise architecture framework and the enterprise product architecture. The pyramid folks have reached out and said, hey, we'd really like to look at your component specification model for the aviation mission computing environment. We said, hey, that's great. We're going to have a UK releasable version probably at the end of this year. We'd be happy to give that to you. On the same side, the Navy has already requested access to that, and so has the Air Force, because again, being able to share what we've already done and get feedback,
right,
not only from industry like we do through the VLC and other things, but from those partners, and they also give us what they've had from an architecture. We then look at, okay, here's the common components, and we actually are linking in components from those other services into our enterprise architecture so that it can be leveraged as well.
Right. So I know probably not today, but working on a process. We've had some previous public release stuff, but we can. We've got an active CRADA with like the Vertical Lift Consortium, so we don't have to go all the way through public release even to get rapid feedback on that. So like the lists of kind of envisioned future components, recognizing that might change. That's something we can actually get in the near term and start kind of fostering that conversation.
No, that's perfect. And I'd like to take you up on that because we've changed the naming convention for the enterprise architecture. We have 1.0, which was released in March. We will be releasing, it's the enterprise architecture 2025 release 1.
Okay.
And so that would be a great venue to make that available to the industry and our partners to review, consume the new content. Oh, by the way, we've also converted it from UPDM to UAF. So
right, and that's in System LV2 as well, right? So,
yeah.
Great. All right, so here's a good question from I saw a couple of different questions come in around the concept of are you going to get access to my black box, or on the different perspective is how do I understand what other black boxes are going to do? So two sides of that coin, and ultimately that came down to how do I do virtual integration? And so there was a couple of questions around that, but I like the phrasing of this one. Digital twins require a deeper understanding of the modules beyond just the interface of the module, to the point where the digital twin needs to potentially access proprietary information. So from the acquiring organization perspective, how do you balance the need for detailed data as part of that digital twin framework? So that was a part of the question, but there were several along that line. So what's your thoughts on that?
So it's interesting. The whole idea of a digital thread, digital twin is super important. And you're right, you have to have the fidelity and access to the data so that you can actually create that, and I'll say, tool chain connection between the physical and the virtual. Now, when it goes to how do I get access, or how do I protect my IP from a company perspective, there are some questions that we're still trying to figure out. Like, specifying the interface to a black box is one thing. Understanding the actual behaviors, that create the input and outputs, that might be an IP issue, but
right.
I need to be able to model that, because part of the whole idea of using digital twins is to being able to, like you said, virtually understand the performance, the attributes of connecting these components together
right.
without physically building them.
Right.
And so there's not a great answer to it. It's still evolving. But from the government's perspective, and I get this a lot when I talk to industry, like, hey, if we give you all our interfaces and we tell you how we do our stuff, well, then we've lost our competitive edge. My response is, I don't want to know your algorithm.
Right. You don't want to know the internals of the black box.
Right. I just want to have the outputs in a standard format, and I want to tell you what the inputs are in a standard format, so that way this is how things are going to talk to me and how you should talk to others. You can then spend more of your time innovating, making your sensor better or your algorithm better, knowing that you're not going to have to go fight to figure out how to take someone else's black box off. change your interface to match that one, there's going to be a common interface.
Right. And I know we've done some demonstrations of this, like the S&T side, we did a mission system architecture demonstration, or MSAT, and that had a capstone event where we proved that we could do blind integration without seeing the internal black boxes. And there are ways when you get to that point of integration where you do individual agreements and have a third party with NDAs in place so that they can do what they need to do to verify integration points. So there's an ongoing work as we move increasingly into that dynamic digital twin environment, and we're eager to see how industry can help you solve that problem together. Let me move on to a couple other questions. I know that one's going to be a fun thing to answer as we drive in, maybe a good keynote topic that that we can put into the summit. So this one was really good. Cost, schedule, and performance data have largely been empirical. Hard to measure kind of those outcomes of MOSA, the promise that it's going to deliver something faster, that you're going to be able to increase quality. So how do you get to the point where you can have actual product deliverable, measurable results for that versus just hypotheticals? Anything that your office is doing to kind of track that?
So let me kind of read back the question. So if the question is, how do I measure the return on the investment?
Right.
From a MOSA perspective. And so one of the things, that I hear is people think that MOSA is going to be a silver bullet or a panacea to be able to achieve all these cost savings. In the long term, I think it will mitigate cost savings, but in the near term, it does require a lot more discipline. And you have to, like Jason Lucas on the Florida program would say, you got to go slow to go fast.
Right.
You got to define what you're looking for. You got to define the components and architecture. Yep. Once that's in place, and that takes a lot of thought, a lot of going back and forth, what you've then created is this environment, not only that it enables commonality, it enables interchangeability and severability. And being able to have that severability from a government's perspective, when the next best thing comes out, I don't have to rewire the whole aircraft. I can drop in that software capability or that hardware capability. Right. From a vendor's perspective, what it does, the return on their investment in complying towards these standards, whether it's a physical standard from a slot profile or a data standard, is they no longer need to work their business development, folks to the death to have that death grip from a proprietary standpoint on a platform. Right. They then get to turn their IRAD on.
So they're kind of extrinsic cost savings for not having to do business the old way.
And it opens up new business territory, because then they can focus their investment on how do I make my capability the best there is. And knowing that I can get my capability onto any aircraft now, because the aircraft now have these common standards, so I can just plug and play.
Yeah, I had an interesting discussion, and this has actually come up a number of times since the first time we had this discussion, and it was from somebody in the test and evaluation community talking about how one of the things you like to do in a test is kind of a pure double blind, where you do it with, and then you have a control group, and then you do it without, and you can't really do that kind of statistical information on a $1 billion program. Let's run a $1 billion program with MOSA. We're going to run the identical $1 billion program this other traditional waterfall way. It's impractical to do that. But one of the things that I think you can do is you can measure directly the impact of speed. There was a good conversation on LinkedIn about this with the idea that how do you balance the delta between speed and quality? And my response was, speed is quality, because my grandfather used to say, if you don't have time to do it over, right, then you better do it right the first time.
Yeah.
And so that balancing of saying you can do it right the first time, but get to a minimum viable product that's of high quality, but just that it's the minimum viable releasable version of that quality, so that you can learn and iterate, rather than trying to delay to add all of the features and then trying to achieve both quality and maximum performance. So I think there's some type of a balance there that we're still approaching in DoD.
Yeah, and just to go back to when you talked about the enormity of a weapon system, and how it may be too big. I look at how FLRAA, from a system engineering and digital engineering perspective, how they're approaching it, breaking down all the components into the subsystems, and they're looking at each one individually, but they're also looking at how they interconnect as a whole. So when you look at the performance of the overall system, they're looking to each one first to say, okay, this piece has to work with that piece.
Right.
What are the critical things I need to focus on and spend that extra time to get right, knowing that those things are now going to be a building block, and so forth, so on and so forth. So again, it's just applying that rigor of design philosophy deliberately. But once the outcome is there, then when I need to change a component or update a component, it's a lot more, a lot faster, a lot quicker.
Okay, great. Couple of questions around this topic. I'll kind of rephrase it this way. We've done quite a bit of work to talk about getting to the evolution of requirements rather than trying to build perfect requirements. We're going to build value streams that help us to understand how we can engage in kind of this continuous conversation of delivery of final value. That's been really good. But as the system evolves and as we follow the philosophy you just described in PM Flora, moving from that single perfect weapon system perspective to an evolving concept of mission systems, how do we not leave the test and evaluation community behind? And this is just especially challenging as we are increasingly moving into a digital engineering world where we are building these component specification models and we may be assembling them in a configuration that we deploy. How do we do that while we're not just saying, hey, test and evaluation, show up and evaluate this end-to-end configuration of a major release?
Yeah, there's a huge opportunity to miss the boat on this one, right? Mm-hmm. And so when I think about MBSE or model-based system engineering, a lot of folks think, oh, I'm just capturing system requirements in a graphical tool that I can use. Well, system engineering encompasses all aspects of development, right? From concept to, sunset. And when you think about not only the test side, but the airworthiness side, right? The safety side, we've made huge strides with, and I'll talk about the airworthiness side first, and I'll go over on the test side, and, to help streamline the process, saying, here's what we're going to have. We're going to have a model. Here's the representations. Here's the interface. It's not just this big paper, stack of, okay, let's weed through it. And that's accelerating the cycle once they have that understanding of how to start using digital models, representations of interfaces, doing the simulations on the testing from an airworthiness perspective. So we've had a great, we're making great strides with our SRD brethren. Chris Collins from OUSDRE, he is all about how do I leverage, the whole idea of digital transformation to not only, reduce my testing costs, but improve its quality.
Right.
And so they've been a pathfinder on a lot of the efforts. They've been working closely with Flora and FAR before, the change of decision was there, saying how do we start getting credit for test events based on the digital twin and some of the prototypes that were built to the spec to then give us not only to mitigate the risk, but give us those performance characteristics before we actually go to the field.
Right.
And so we're not done. We're still forging new ground, but this seems to be the first time where there's alignment from these different domains saying we got to do things differently. We are going to embrace the technology that's available to enable us to do that. And now the program offices are saying, yes, let me give it to you this way. Okay, this is what you need that way. Right. So I think we're making progress.
Okay. And so that's kind of bringing back a philosophy in a very different way that's always been there about involve the community early. But in this case, it's involve early and often almost becomes involved continuously. And it's bringing, I know like DOT&E has put out some new policies recently where they talked about instead of thinking about that acquisition cycle where you have research and development and then critical design review and then testing, it's more like research, design, prototype something, get a minimum viable product, test it, and that's one community, and then move to the next cycle of doing the same thing. So it's taking that what we've always done, and instead of trying to do it over a 10-year cycle, to try and do that over a very very short iteration to get to the next release, the next release.
I like to call it almost like a double helix approach, where you have a DNA helix, where you have these the crosses, and each of those intersection points is an opportunity for the process to start again.
Right. Opportunity for us to reinvent the systems engineering bee to the systems engineering helix, I think would be really fun.
Oh, it would be good.
Yeah. Okay, great. So there have been some really good additional questions, but we've got about 5 minutes left in our time.
Really?
And so I would
like to do another one of these.
Yeah, we will definitely have to do another one. And I think we are going to be actively planning, like I said, it's some type of a spring all-day in-person event like we did with the GovMeets Institute in DC back in November. We are certainly going to have some more webinars, right? So thank you all for joining in. And I'll give you the last 5 minutes to give closing thoughts about where we're headed from here in the future of APO E&A, maybe where we might spot you with a hat.
Next time you see me, I might have a different hat because my sister's turning 50, so I'm going back in February to the BVI. So we'll see what yacht rock type attire that I'm bestowed on that trip. But when I'm looking at PO Aviation, one of the things that I really like about where we're at right now, is General Phillips really is all in on this vision, right? And one of the first things that when he took command, he sat down all the PMs and said, hey, we are a band. We are all going to play on the same sheet of music. We're going to play on the same tune in the same time. And I've seen that, repeated, like there's so much collaboration now, PM to PM. There's a collaboration at the enterprise level. We've stood up what we call the Enterprise Board of Directors, which used to be the MOSA Board of Directors that was only looking at MOSA things. Now we're looking at any activity, whether it's an investment activity or program of record or development, that has applicability to more than one weapon system. So it could be a component that could be reused somewhere.
Assured P&T,
Assured P&T, communications, architectural, components, like a modern, effects launcher, something that could be reusable on more than one platform. That's an enterprise interest. And so the new Enterprise Board of Directors consists of all 9 of PO Aviation's, 06 PMs as voting members. There's 3 different APOs. There's engineering and architecture. There's programs, plans and resourcing, the business, APO, and then there's the log PEO, APEO,
right, as
voting members, and the chief of staff. And we bring, nominated topics from the PMs of, hey, does this need to be an enterprise thing? Does this have a modularity? Do we need to steward this as an enterprise interest to ensure alignment so that we're all playing as one team from PO Aviation? So I'm super excited about that. That's really helping, not only knock down barriers of stovepipes of excellence, but it's enabling collaboration, platform to platform and industry provider to industry provider, because we're all in it together. So that's one of the things that I'm excited about. The other thing is, what I'm excited about is really seeing a change in the engineering workforce, where it's not just about give me my requirement. They're starting to ask, how does my requirement affect my brother or my sister platform? Or how do I know I need something from them, how do I collaborate? So we're seeing a lot of that happening, which then comes back up through additions into the specs that we have, the CSMs. And so for me, I'm like, yes, this is great.
All right, so we're really thinking about this now. It has gotten, one of my professors at MIT used to say that, culture trumps strategy every day of the week, right?
Yes.
And strategy is what you put on the wall, and culture is what you put in the water, right?
Yes.
And so it sounds like this has really gotten into the water at PO Aviation. This is in the culture.
100%.
That's fantastic, because then it's not going anywhere. This is the way we think now, and that's thinking about a system of systems. And now we're taking that from PO Aviation and the system of systems in Army Aviation and bringing that to how can we think that way across the DoD. And I think that is going to have fantastic future benefits.
Yeah.
So I think that brings us to our time. I know there are a number of questions. There's so many good questions in the chat. So I'm going to take a commitment to look at those afterwards.
Sure.
And email you back and forth on some ideas and things that we might be able to get out there into the community digitally this way instead of digitally with cameras.
Yeah, that sounds great.
Okay, great. Thank you very much for your time.
Appreciate your time.
All right, and thank you all for joining. We'll see you at the next one.